A plasma arc cutter consists of a power supply and a torch. The power supply is very similar to a battery. It can provide a DC electrical current. The carriers of this electrical current are called electrons, and electrons carry a negative charge. The electrons will flow from the negative terminal, around the circuit, and back to the positive terminal. There are two consumable parts connected into the circuit. They are called the electrode and the nozzle. Consumable simply means that they are slowly damaged by heat and by contact with the arc. They eventually wear out and need to be replaced. Other consumable parts on a torch include the swirl ring, the retaining cap, and the shield. The consumable parts control the size and shape of the plasma arc, and they can be optimized for specific applications or to emphasize a particular attribute like cut speed or cut quality. Some consumable sets are intended for cutting thin metal as artwork. These consumables are used with minimal standoff and cut a very narrow kerf. Other consumables are intended for making fast cuts in thicker material or gouging. These sets create a larger, wider arc. In a plasma arc cutter, the torch is connected into the circuit with the electrode at the negative terminal and the nozzle at the positive terminal. When the electrode and the nozzle are conductive and are touching each other, current flows through them unimpeded. There needs to be a gap in that circuit in order to make an electric arc. The power supply of a plasma arc cutter provides process gas, usually compressed air for handheld systems, to the torch. One way of creating an electric arc involves using the pressure of the process gas to separate the electrode and the nozzle from each other. Starting a plasma arc cutting torch by separating a shorted electrode and nozzle to form an arc is called contact starting, because the electrode and nozzle started in contact with each other. When the electrode and nozzle separate while already conducting current, the electrode emits a stream of electrons from its hafnium tip. As the electrons accelerate across the gap, they contact neutral gas molecules with enough force to strip more electrons free. Then the free electrons are re-accelerated toward the nozzle by the electric field, and the positive ions are accelerated toward the electrode, making even more collisions possible. These collisions create more and more positive ions and free electrons. A cascading column of collisions forms. It radiates thermal energy and light energy. This is plasma. It's similar to the spark created by pulling the toaster plug from the wall when the toaster is running. The difference is that the spark from the toaster plug is momentary, but the plasma arc power supply is designed to feed power to the spark, instantaneously enlarging the spark into an arc. The arc that forms between the electrode and the nozzle is called the pilot arc. Gas from the power supply is used to force the pilot arc out of the nozzle orifice. Once the pilot arc has been established, the workpiece needs to be brought into the circuit. The important step is converting the pilot arc, between the electrode and nozzle, into a transferred arc, between the electrode and the workpiece. As the torch approaches the workpiece and the pilot arc contacts the plate, the nozzle and workpiece start to share the plasma current. The power supply forces all the current to go through the workpiece. The power supply increases the current to the cutting level, and metal cutting begins.